As a society, how we produce things today is find some source in the ground, extract it, process it, produce a product, and then repeat the process until we got nothing left. Biology self-replicates. So you plant a seed, and that plant self-assembles itself. So it's manufacturing without factories. Imagine you made the first iPhone and it just went off and made copies of itself. What we're doing at Gingko is providing the technology to enable you to program biology to make stuff.
A team of PhDs from MIT started Gingko Bioworks in Boston, just a few miles away from their alma mater. Inside, they're building tools for a future where factories stop manufacturing goods and start growing them.
At the heart of biology is digital code in the form of DNA. We have now the ability to read that code through DNA sequencing and the ability to write that code with DNA synthesis. And if you can read and write code, you can program. Can you program biology to make stuff? Yes, because DNA is code.
Before they can grow their own iPhones, Gingko is focusing on something simpler, reprogramming microbes like yeast to produce artificial flavors and scents. The company is fine-tuning the process in this robot-filled lab.
So this is Bioworks 2. This is our second-generation lab. If you zoom in, it looks like a kind of regular academic lab, but as you zoom out and see all the robotics, that's what we're trying to do here, make things move faster.
Right now, Gingko is using genetically modified yeast to create a peach perfume for a client in the fragrance industry. To do that, their researchers first study the part of the peach's genetic code that carries the desired scent. They can then compare that with the yeast DNA and modify it to produce a similar smelling substance. Then the process becomes a lot like brewing beer. The yeast grows and multiplies and produces that peach scent as a byproduct. Gingko can extract out that peach scent for clients and give yeast samples a hearty sniff.
Each of these is a different gene combination that's going to make a slightly different smell. So let's see what we got.
Well, it smells a little vinegary, which I think is the yeast.
Yeah.
Yeah, kind of fruity smell.
Samples that pass the smell test are destined to be inside perfume bottles and the like. But once you really start thinking about it, you can see this technology applying to some pretty unexpected places.
What if this was a microbe that could live directly on your skin? And so on your skin, you're producing your perfume. So you don't need to spritz yourself with perfume. Your microbiome is just producing that scent on its own. A lot of the smells that you might associate with human bodies are actually already coming from microbes. So imagining that those microbes might be a little bit different and make a little bit different smell isn't that hard to believe.
Things are looking good these days for Gingko. They recently bought a DNA splicing company and raised $100 million from investors. It's too soon to say if they'll ever make the quantum leap from perfume to grow your own electronics, but Gingko sees its gene-modified yeast as the first step toward a factory where biology can make almost anything.
In the future, we could use biology to make a semiconductor chip. If you look into biology, its ability to place atoms is actually superior to Intel's today, right? So if you just knew how to program it, you could do that. The applications for this are sort of endless.